Okay, welcome to this short video about conducting repeat measures of ANOVA. As I had explained in my previous video, repeat measures of ANOVA is very popular to understand the effect of experimental stimuli on subjects. Usually it is carried out when you have a before and after measurement of some variables, and in between you have a experimental effect or experimental stimuli. So I'm going to look at a classical problem of repeat measures of ANOVA, where repeat measures of ANOVA is used, which is an effectiveness of a training program in an organizational setting. So a group of salespeople were given a special training on sales effectiveness. Since we had invested a lot of money and time on this sales training program, we really wanted to test whether the sales training program was impactful or not. So in order to do that, we developed a research design wherein the sales training program was the experimental stimuli, or what we call as the independent variable here. And the dependent variable was the sales conversion ratio of individual salespeople measured before the sales training program and after the sales training program. So the sales conversion ratio is typically the number of calls which get converted into actual sales. It is usually measured as a percentage. So here we measured the sales conversion ratio of each salesperson for a 1 month period before the experiment or the training program here, and then after the training program we again observed the same set of salespeople and then measured the sales conversion ratio for each of the salespeople. And then we wanted to see whether there was a significant change in sales training program by conducting this statistical method called repeat measures of ANOVA. So I will just explain how this is conducted and how the results are interpreted in a SPSS program. The data has been entered here. As you can see, there are 15 salespeople. For each salesperson, we first measured the sales conversion ratio for 1 month prior to the training program and then 1 month after the training program. So for instance, for the first salesperson, the sales conversion ratio was 43%, which means that 43% of the calls that he made were converted into an actual sales. And after the sales training program, for the next 1 month, somehow it increased to 50%. So for the first person, probably there was an impact of the sales training program. Similarly, we looked at the second person, which increased from 36% before and went into 40% after. For the third person, however, it impacted not very much because it increased only from 28% to 29%. But we really wanted to know, like for instance, for the 14th salesperson, it actually decreased from 23% to 22%. So we really wanted to know whether there has been a real impact of the sales training program. In order to conduct repeat measures of analysis of variance, first we should enter the data in this format, wherein each row is a subject, and then you have data about a previous the data prior to the experimental stimuli and after the experimental stimuli. So to conduct this, we go to the menu and pull out Analyze. Under Analyze, there are so many different statistical techniques which you could use, but we go to a statistical technique under General Linear Model, and from there we go to Repeat Measures. So it opens a new window, as you could see, and it says what is the factor. and the factor name is the name of the independent variable. So we could continue with the word factor, but just for the sake of making it easier for you to interpret, I use the word training program. And how many levels? Here you have 2 levels, which is before and after. It could actually have more levels. Maybe you could measure after 1 more month and see whether the effect of the training program is just for the next month, or actually is it enduring? Has it permanently changed the conversion ratio of sales people? But we are not doing it here. Therefore, we only have 2 levels. And then a new box comes up called add. So we click that box add, which means that the training program comes up inside this small box, and against the training program you have a small bracket which indicates 2, which means that training program has 2 levels. So we have to define these 2 levels. What are these 2 levels? So for that we go to the menu item inside this window called define. So as you open this window, a new window opens up, and there you have to define what does 1 mean under training program and what does 2 mean under the training program. So we put before as 1 and after training as 2. Okay. Now there are so many other menu items. You could explore them if you want. One menu item which could definitely do is to plot, which could usually look at plotting the training program if you want on the horizontal axis, or if you don't want, you don't need to do it. And then in options you could look at display means for the training programs. You could look at the descriptive statistics. Any of these things you could use, but for the time being descriptive statistics is all that we need. I don't want to make it more confusing for you at this stage. So we click continue, and here we again click OK. So what do we have here? This is the output for our experiment, and it shows that there are 15 items before and 15 items after. 15 subjects before and 15 subjects after. And the mean value for the before training program conversion rate was 43.53, and after training program the mean value was 47.646. So therefore the mean value, there is a significant difference between before and after. Now what is the most important part of this test? It is to look at the multivariate test and the significant levels of these tests. I don't want to explain too much about this part. This part shows the different ways in which the test was conducted. Obviously there are different ways in conducting different mathematical algorithms using which we conduct repeat measures of variance. Each constructs a particular type of test statistic, which is then connected to an F statistic, F distribution, and then you look at the F distribution and find out what is the significance level of that F distribution. So as you could see, for all of these 4 different types of repeat measures of analysis of variance algorithm, you get a significant value of 0.000, which means that the significant level is 0 and is definitely less than our the cutoff significant value of 0.05, which means that the repeat measures of analysis of variance test is successful, and there is a significant difference between the mean value of before training and after training. So we can say with almost 100% confidence that the before training value and the after training value are really different. And as you could see, after training is higher than before training, and they are also significantly different. Therefore, it would mean that after training there was a, if not a great, but at least a statistically significant difference in the sales conversion ratio of each of the salespeople. Thank you very much.